testing. This is an example from hypothesis testing. Before I move into the example, let me give you a brief review of what we did in chapter 9 so far, and then we will move on towards the example. In chapter 9, we said that sometimes we are interested. Suppose you have a population on variable x. This population is modeled by f of x. For this f of x, sometimes you have an unknown parameter mu, where sigma square is sometimes known, sometimes unknown. This is your interest. This is where you are interested. To estimate this quantity mu, what do? You take a representative part of this population and you call this representative part a sample. This sample is on n values. From this sample, you compute x bar, which is nothing but the sum of values divided by the number of values, and you call this x bar to be a point estimate of this mu. We did this in chapter 6. Then in chapter 7, you said that this x bar over repeated sampling either exactly or approximately follow a normal distribution depending upon the parent distribution. If parent distribution is normal, this will be exactly normal. If parent is not normal, this will be approximately normal with the same mean mu, but the variance is sigma square over n. Then we use this result to convert this x bar into an interval estimate. We said there are two cases. Case number 1, when sigma is known. You said this x bar can be converted into an interval estimate using a critical value from z, and when sigma is unknown, this x bar can be converted into an interval estimate using a critical value from t. And then there was a limitation of the second case. If the degree of freedom is not available in t, then you can approximate the critical value from the z table. But I'm not going to write that one. Now, in this chapter, chapter 9, we are going to extend this concept to testing some statements about this unknown quantity mu. Sometimes we have a claim about this mu. Someone claims that the average of the population is more than 7 or less than 7 or equal to 7 or less than equal to 7 or more than equal to 7 or not equal to 7. So we have sometimes some claims about the unknown population parameters. These claims are called hypotheses. And the procedure of testing whether this claim is true or not, that procedure is called hypothesis testing. The chapter's name is hypothesis testing. So hypothesis testing is a procedure where you test if the claim about a population parameter is true or not true. The whole procedure is called hypothesis testing. Now, in these hypothesis testing questions, what we are given is we are given a question which has a claim about the population parameter. We said that first we write that claim in terms of a statement. Then we write the opposite of that statement. Now we have two hypotheses. The one with the equal sign, we call it H0, and the one with not equal sign, we call it H1. And then we compute the test statistic and get the critical value from the Z table and compare the statistic with the critical value and decide about whether to reject or to retain H0. Now let us have an example, and from this example I will explain to you how everything is done. If you read this example, it says that ASTM specifications, they require that the propellant be safe only if the mean burning rate is at least what? At least 50. What is the requirement? Okay, let's continue to read. Assume that the burning rate is normally distributed with a, now this is important, with a, this information is pushing you towards Z or towards T. Towards Z. It is pushing you towards Z. Look here, the map. When sigma is known, in chapter 8 or chapter 9, both same thing. You are pushed towards Z. When sigma is unknown, you are pushed towards T. So this information that the sigma is 2.5, it is pushing you towards Z. Then it says that a random sample of size 25, n is given to be 25 information. And the sample mean. Some questions might give you the sample like 5 values and you have to compute the sample mean yourself. Some questions will give you the sample mean. Here we give you the sample mean. Sample mean is 48.2. So let me write that information what's given to me. What's given to me is that sigma is 2.5. What's given to me is that n is 20. And what's given to me is that x bar is 48.2. Now the important part. Look at the question. What does the question says? Using the critical value approach, you have to test what? Read the yellow text and see what is required to be tested. You have to test what? That the true mean burning rate. What is true mean burning rate? It is mu is less than. What is less than? Less than 10. Less than what? Write it as a notation. The question says mu is less than 50. This is the question. So again, the procedure is what? Read the question and write the question in terms of a hypothesis. This is what I did. I read the question and I wrote it as a hypothesis. Just to remind me that this is the statement of the question, I wrote in bracket that this was what was to be claimed in the question. What is the opposite of this statement? Less than 50. What is the opposite of less than 50? Greater than or equal to 50. Now we got two statements like we did in the previous class, the class before previous class. We said that we will read the statement of the question and write it. Then we will write the opposite of that statement. We have two hypotheses. One of them becomes H naught. One of them becomes H1. Which one becomes H naught with the equal sign? Which one becomes H1? The one without equal sign. So the one with equal sign becomes H naught, null hypothesis, and the one without equal sign becomes H1. This procedure will be applicable on any question related to chapter 9, 11, and 12. Chapter 9, 11, and 12. For the final exam, all three chapters contain hypothesis testing. And this procedure will be applicable on any of those questions. Number one, read the question. Number two, write the question statement in terms of a hypothesis. Number three, write the opposite of this hypothesis. And number four, the one that contains equal sign, call it H naught. The one without equal sign, call it H1. Once you have H naught and H1, then you go to the formula sheet, and the formula sheet will tell you that for testing hypothesis related to mu, there are two tests available, a Z test and a T test. To construct the confidence interval, you have to use these formulas. If you are interested in hypothesis testing, you use these formulas. So because our sigma is known, we'll be testing that hypothesis using Z or T. Using Z. So our Z is X bar minus mu divided by sigma over root of n. Now put the values inside this one from the question. What is x bar given? 48.2. What is the value of mu that you are testing in the question? This mu is this value that you are testing in the question, which is 50. What is sigma given in the question? 2.5. And what is n? 20. Calculators.
It's 3.2199.
Minus 3.2199. Correct? Okay. Once you have this value of z, the final step for making decision about whether H naught is true or not, for the final step, you have to refer to this table. In this table, we see that if your H naught and H1 is, your question is of this type. Look at the sign of H1, less than. Your question is of less than type. The question you are solving is of less than type. For less than type, you need to go to the Z table and look for a critical value, Z alpha, and then if your value that you computed, which is minus 3.2199, is less than that value, you reject H naught. If it is not less than that value, you fail to reject H naught. But pay attention to this alpha. You will not look for alpha by 2 in the table. You will look for alpha in the table. Here you will look for alpha by 2 if your H1 is two-sided, not equal to. For one-sided hypothesis, you will look for alpha in the table. So go to the Z table and look for alpha. What is alpha? Alpha is the level of significance. And read here what is written about alpha. What does the table say? The table says that the level of significance alpha is either given in the question. And what if it is not given in the question? We assume it to be 0.05. Now read the whole question and see where is it given. "95% or 5% or 99% or 90% or 1% or 10%. Is it given anywhere? No, you will assume it. So assume alpha to be 0.05. Go to the Z table and look for 1 minus alpha, which is 0.95. Why? Because Z table is given for the less than side, convert it to greater than, and look for 1 minus alpha. Go to the Z table and look for 1 minus alpha, which is 0.95. So look for 0.95 in the table. Where is 0.9500 in the table? Is it there? Do you see? 0.95 is in the middle of these two values, almost the middle of these two values, correct? And these two values correspond to what? They correspond to 1.64 and 1.65. So what is in the middle of 1.64 and 1.65? 1.645. So you can take 1.64, you can take 1.65. 1.65 I think was far, 1.64 was closer, but the better thing is to take 1.645 because the value was almost in the middle. Z 0.05 is 1.645. So the rule becomes that we will reject H naught if my value of Z is less than minus 1.645. This minus is coming from the table there, less than minus Z alpha. Okay. Now, is your value less than minus 1.645? This value. Is it less than minus 1.645? Yes. So what will you say? You will say as minus 3.2199 is less than minus 1.645. So we reject H naught. This statement is called a decision. Remember, this statement, what I wrote, is called a decision. After making decision, you have to make conclusion. Conclusion means you talk in terms of the variable itself. The variable was mean burning rate. So now go back. You rejected H naught, which means you go with H1, which means the statement of the question was true. So what will you conclude? That the true mean burning rate is indeed less than, it is indeed less than 50. That was H1. Because you rejected H naught, you go with H1. H1 was the question actually. The question says that the mean burning rate is less than 50. So you confirm that the mean burning rate is indeed less than 50. Clear? Let's move on to part 2. In part 2, we have to do exactly the same thing, but in part 1, we followed the critical value approach. That is, we computed the value of Z and we compared it with the critical value. If it falls in the rejection region, we reject. If it doesn't, we fail to reject. Here, the question says use the p-value approach. So again, refer back to the same table. We are given an expression for the p-value. We have to find this p-value. After finding this p-value, we will reject H naught if the p-value is small. How small? Less than alpha. Again, if alpha is not given, you will assume it. So let us take this expression and compute the p-value. To compute the p-value, again, you need the value of Z. We computed Z to be minus 3.2199. Now, the slide says that p-value is the probability in Z distribution less than minus 3.2199. This is what the slide said. Probability of Z less than Z naught. Z naught is the value that you get from the question, which is minus 3.2199. Now go to the Z, will the Z table give you less than probability directly, or you want to convert it to greater than or something? Z table is based on less than probabilities or greater than probabilities? Chapter 4. It's already less than probability. You don't need to use the complement. So go to chapter 4. Again, the values of Z, how many decimal points are they available up to? 2. So you must convert it to 2 decimals. This probability, you can get it from the Z table. Go to the Z table and find the area below minus 3.22. What is the area below minus 3.22? Minus 3.22 will be somewhere here. Minus 3.22. What is the area below minus 3.22? 0.00064. 0.00064. Is this very small? What is the quantification of being small? Alpha is the quantification of calling it small. Is alpha given? No. What will you assume? 5%. Is this less than 5%? Yes. So you will say as p-value is less than 5%. So we reject H naught and conclude that, what do we conclude? Conclusion is different from decision. Decision is reject H naught or do not reject H naught. What is the conclusion? Answer the question in terms of question statement. The question did not ask you whether you reject H naught or accept H naught. The question said that test whether the true mean burning rate is less than 50 or not. So what do you conclude? No, you reject H naught. Your H naught was mu greater than equal to 50. Your H1 was mu less than 50. So you reject H1 and you go with this hypothesis. So you go with the claim that the mean burning rate is indeed less than 50. One of the mistakes that I see very commonly is that when you compute the p-value, look here, this is all the procedure for the computation of p-value. This is where I computed p-value. Throughout the circle, within the circle where I computed p-value, did I use alpha anywhere? So during the computation of p-value, alpha is never used. At the end, alpha is used to compare the p-value with. Right at the end, you compare the p-value with alpha. But during the calculation, what mistake I see is students usually find the probability of z less than z alpha by 2, less than minus 1.645. And they get 0.05 exactly, which is equal to alpha. So during the computation of p-value, alpha is not used anywhere. Let me write it here. Alpha is not used for computing the p-value. It is used for making the decision at the end, for comparing the p-value, whether it is small or not. Let's change the question. The top 3 or 4 lines are the same. The question says, again, using the critical value approach at 5%. Now they give you the level of significance. Now the question is giving you alpha to be. Test the hypothesis that I'm going to highlight what they are asking us to test. What are they asking us to test? Mu is equal to 50. What is the opposite of this statement? Not equal to 50. Which of these two statements contain equal sign? The first one. Which one does not contain equal sign? The second one. Just for last step where you want to make conclusion, just write here that this is your question. The statement of the question is in H naught now. In previous question, it was in H1, if you remember. The question was in H1. Now let us proceed with the critical value approach. We have the same data, so the z value will be same. It is x bar minus mu divided by sigma over root of n. It will be 48.2 minus 50 divided by 2.5 over root of 20. And it will be minus 3.2199, right? Now to define the rejection region, go back to the slide. And the slide says we reject H naught if the absolute value of Z naught is greater than Z alpha by 2. And we know how to get this value from the table. How do we get this value from the table? 4 steps, chapter 8. What is alpha? What is alpha by 2? What is 1 minus alpha by 2? So look for this 1 minus alpha by 2 in the table, and the corresponding value of Z is the critical value. What is that? 1.96. We remember this value is very popular for chapter 8 for 95%. It's 1.96. Now, is the absolute value of 3.2199 greater than 1.96? So we reject H naught. What is the conclusion? The mean burning rate is not 50. It's different from 50. Whether it's more than 50 or less than 50, we will not comment, but it is not 50. Next question. It's the same part 3, but here they're asking us to use what? Yeah. Using p-value approach, test the hypothesis that the true burning rate, the mean burning rate is not 50. Let's write down the statement. Let me highlight the statement. This is what the question is asking us to test. Write it as a hypothesis. What is this? Correct? What is the opposite? Which one contains equal sign? Now the question is in H1 again. Then compute the Z value. 3.2199. Go back to the slide, and the slide for not equal to two-sided H1 will tell you that the p-value expression is 2 times probability of Z greater than absolute value of Z naught. Put the value of Z naught. What is Z naught? Minus 3.2199. So this is 2 times. What is absolute of 3.2199? Minus plus 3.2199. Correct? Now, there are two things here. Number one, does the Z table give you greater than probabilities? The answer is no. What does it give you? Less than. Second thing, does the Z table give you the value of Z more than 2 decimal points? No. You have to round it to how many decimal points? I'm going to do the two things in one step. This is 2 times 1 minus Z less than 3.22. I rounded to 3.22 and I also converted it to less than because of the limitation of the Z table. It gives me less than probabilities. Now I will go to the Z table and look for the area below 3.22. And the area below 3.22 is 3.22 plus 3.22. Look at the last row. 3.20, 3.21, 3.22. What is the area below 3.22? 99936. 99936. Calculate this. 2 times 1 minus 0.99936. Is this p-value small? Is this less than alpha? Yes, so we reject H naught. What is the conclusion? Again, write the hypothesis in terms of question statement. What is the conclusion? Yes, so what is the conclusion? In terms of conclusion, think like you are telling this statement to a non-statistician. The non-statistician doesn't know what is H naught. He doesn't know what is H1. He doesn't know what is mu. He knows whether the true mean burning rate is 50 or is it not 50. So the conclusion is it is not 50. or we can say it is significantly different from 50. Again, we will not comment if it is more or less. Construct, interesting question. Construct a 95% confidence interval for the true mean burning rate and test the hypothesis if the true mean burning rate is 50 or not. Again, what is the question? You have to test the same hypothesis. What is the question? Correct? Now we'll use the third approach. What is the third approach? The third approach, there is critical value approach, there is p-value approach, and there is confidence interval approach from chapter 8. That approach says construct the confidence interval like you did in chapter 8. So I will construct it. What was the formula? The formula was, I will construct it here. The formula was x bar plus minus z alpha by 2 times sigma over root of n. I will plug in the values. 48.2 plus minus. For 95%, what is the critical value when alpha is 5%? Popular value 1.96. Sigma is 2.5. N is square root of 20. Can you compute these two limits with plus and minus and give them to me? One of you computes the upper, one of you computes the lower.
Uh, 47.104.
This is a 95% confidence interval we computed. Now go back to the slide. Again, this slide is all chapter 9. This slide is all chapter 9. This slide says that for testing this hypothesis, the question might ask you from three approaches. There are three methods you can test this hypothesis. You can test it using the critical value approach. That is, you compute the value of z, compare it with the value of from the table and make decision. The second approach is you compute the p-value and then compare it with alpha. And the third approach is you construct the confidence interval. And if the value of mu that you are testing belongs to the interval, you go with H naught. If it doesn't belong, you reject H naught. Now, my question is, read this one. This approach says that we will reject H naught if the value of mu 50 that we are testing in our hypothesis, if it belongs to the interval or not. So go back to the question and check here. Does this value 50 belong to this interval or not? Belong means, is it inside the interval or outside the interval? So we will say, according to the confidence interval approach, we will say as 50 does not belong to 47.104 all the way up to 49.2957. So we reject H naught. And conclude that the mean burning rate is not 50. So what we learned today is that this hypothesis can be tested using three approaches. It can be tested using the critical value approach. We tested it here in part 3. Critical value approach. We computed the value of z. We compared it with the critical value from the z table. And we said that if this z is absolute of z is more than critical value, we reject. If it is not more, we fail to reject. We tested the same hypothesis using the p-value approach. We have a p-value expression. We find the p-value from that expression. If the p-value is too small, we reject H naught. If it is not too small, we fail to reject H naught. And the quantification or the cutoff for small is what? Alpha is the cutoff for saying if it is small or not. And the third approach is, for the same question, the third approach is we construct the two-sided confidence interval. And if the value of mu belongs to the interval, we go with H naught. If it doesn't belong to the interval, we reject H naught. The confidence interval, chapter 8, we did not cover the one-sided confidence interval. So as a result, you will see that you will not be asked question out of confidence interval for the one-sided hypothesis. You will see the cross marks here and the cross mark here. So for one-sided hypothesis, we will test you only from two approaches, either the critical value approach or the p-value approach. But for the two-sided, we may ask you for the third approach also. That is, we may ask you for constructing the confidence interval and test the hypothesis using the confidence interval approach also. This cross does not mean that this approach does not exist. It does exist. One-sided confidence intervals were there in chapter 8. If you remember, we did not cover it, but one-sided confidence intervals are there in chapter 8. But we did not cover it in this course, so you will see the cross marks here. Again, this one slide is whole chapter 9. This one slide is whole chapter 9. For the whole chapter 9, I will keep coming back to this slide. What will change in this slide is in the next topic, when sigma is unknown, I will replace z by t everywhere, sigma by s and z by t. No change in sign, no change in anything. Everywhere I will replace z by t and I will replace sigma by s. When I'm talking about the proportion, I will change everything into proportion. All the signs will remain the same. So this one slide is your whole chapter 9, all chapter 9. So let us finish the class here.